Okay, so we want to calculate the correlation R between the two variables x and y for a sample of individuals. Which of the following correlations are necessary for R to be a meaningful measure of association? So now we have already learned a lot of things about correlation, and correlation is represented by R, denoted by R, okay? So correlation, we are talking about correlation, and correlation is denoted by R, okay? So now they're asking that there are 3 points. Which of the 3 points are correct about correlation? So very important question. So question, what is correlation? Correlation is between the two variables. It is a measure of linear relationship between those two variables. What is correlation? Correlation
Or
is denoted by R. It is measure of linear relationship.
Restaurant.
It is measure of linear relationship between two variables. Keeping noting the small points on your notebook, this will help you learn the things in a better way. Keep
I'll
writing
say
that
what?
correlation is denoted by R. It is a measure of linear relationship between two variables. Is correlation positive or negative?
Both.
Both. Correlation can be either positive or negative. Can be either positive or negative. So these are the few things about correlation. Now we would need to tell that which of the 3 points are correct and which are not correct. So number 1 point says x and y are both quantitative variables. So if we have to find out the correlation for the two variables x and y, then the two variables should be quantitative variables. So yes, it is correct because correlation is always defined for the quantitative variables. For the categorical variables, we cannot define the correlation. If the variables are categorical, we can't define correlation.
Okay.
It means that x and y, both variables, should be quantitative, so this point is correct and necessary. Second condition is the relationship between x and y is linear. So yes, the correlation is only described for the linear variables. Okay, correlation is a relationship for the linear relationship between x and y dash. So if the variables are not linearly related, correlation is not a suitable measure. If I'm writing here, if variables are not linearly related, then correlation is not suitable. Okay. The last one, so it means number 1 point is necessary and important, number 2 point is necessary and important. Number 3 point, x is explanatory variable and y is response variable. So is it necessary that there should be one explanatory and one response variable? No, it is not necessary because correlation only describes the extent to which x and y are linearly independent. It is not a measure of dependence of one variable to the other. So it is, correlation is not measure of dependence, not measure of dependence. So it does not matter if the correlation is explanatory variable or response or whatever the variable is. So third condition is not necessary. So only the necessary and important conditions are 1 and 2. So it means option C will be the correct answer, as 1 and 2 are important and necessary conditions for the correlation. So this question is very important as this is telling us a lot of things about correlation. It is also, first of all, it is giving us the definition for the correlation, that what is correlation. Correlation is basically measure of linear relationship between the two variables. Then correlation, the important point that you should know, Abdullah, especially, that correlation is denoted by R, because when I say to calculate R, you are just blank at what is R. So correlation is calculated, denoted by R. This is important. And the last thing important is correlation can be either positive or negative. Then there is a thing important, that correlation can only be calculated for quantitative variables. It cannot be calculated for categorical variables. The next important point is correlation is always calculated for linearly dependent variables. If they're not linearly related, correlation is not a suitable measure. Third is that correlation is not dependent upon the measure of dependency, like explanatory or response variables. They are not dependent on this. So these are all points about the correlation which help us answer question number 1. Okay, I'm giving you 1 minute to just read question number 2 and think about it.
Okay.
Okay, to determine whether the correlation for each of the following pairs of variables is most likely positive or negative. Have you already read out the question?
Yeah.
Okay. So X number 1, it says that whether, so we have already learned that correlation can be either positive or negative. Now they are saying that tell which of the following are positive and which are negative. So how we will know it if a correlation is positive and how we will know if the correlation is negative. So correlation between the two variables I'm writing over here. The points I'm writing are really very important. They will be helpful in multiple choice questions and other practice questions both. So you must write down somewhere correlation between two variables is positive when increase in one variable results in increase in other. Similarly, correlation between two variables is negative when increase in one variable results in decrease in other.
Yes, done.
In decrease in other variable. Okay. So now we know that correlation can be either positive and negative, and it's positive when one variable is increasing and other is also increasing. And it's negative if one variable increase and the other decrease. So when we know these 2 points, we can easily answer MCQs number 2. So MCQs number 2 says which of the pair are positive and which are negative. So the first pair is speed of the wind in a snowstorm and visibility. So speed of the wind in a snowstorm, when the speed of the wind in a snowstorm increases, what happened to the visibility? It decreases, right? When snowstorm increases in the wind, the visibility decreases now. So it means the correlation over here is the negative one. Now the second MCQ says global supply of oil. So when is equal to price of gasoline. So price and supply are directly related to each other. When supply increases, the price will also increase. When supply decreases, the price will also decrease. So this is positive. The third one is number of people in line at a bank when you arrive is equal to time until you're served by a teller. So when there are more people in a line at a bank, the longer it will take to get service by the teller. So correlation. So more people in the line, more time will be taken. So it means it is positive. So you can see it, we are checking that if both of the variables are increasing, it's positive. If one is increasing, other is decreasing, it's negative. So from this, number one is negative, number two is positive, number three is positive. So option A will be the correct answer. Did you get it?
Yeah.
Any question up till now?
No.
Okay. So now I'm just clearing the board and try question number 3. I'm giving you 1 minute. Have you tried it?
Yeah.
It's related to the one we have already done. So it's which of the following pairs of variables would be most likely to have a correlation r equal to 0.5. So it means we checked it, but if the correlation would be 0.5 or not. We can approximately check it. So select a sample of commercial airline flights leaving from the airport one day. So some of the commercial airline flights were leaving from the airport one day. So X is the flight distance in kilometers and Y is the flight distance in miles. So the flight distance in kilometers and miles are likely to have higher concentration or more than 0.5. More than 0.5. Select a sample of grocery stores. Let's suppose we have a sample of grocery stores. So price of orange juice and amount of orange juice sold. So price of orange is related to the number of orange sold since the demand of a product is inversely related to the price. So obviously demand of the product is inversely related to the price. So as the demand increases, the price is not important to increase. So it means this is a negative correlation because there is an inverse relation, so it would be negative. Select a sample of stat 1000 students. X is the number of incorrect answers on the midterm, Y is the score on the test. So number of incorrect answers and score on the test is a negative relationship. Select a sample of adults in Winnipeg. X is equal to IQ level of the adults and Y is equal to weight. So IQ and weight are not related because they are not independent characteristics. So a person's IQ level cannot measure the weight. So we cannot relate them. They are not related. Select a sample of male student at the University of Manitoba. X is equal to height, Y is equal to shoe size. So height and shoe size of a person has a positive correlation because as the height of the person is like if it is a small kid, it may have a small shoe size. If it is a big one adult, it is a big shoe size. If very big adult, very big shoe size. So shoe size basically increases with the height. So it means this is a positive correlation. It equally increases, so it can have a R 0.5. So our correct answer is E. Three of them are not correct because they are negative, and this has the kilometers and distance in miles, so this is a very big difference, so it may be more than 0.5, not exactly 0.5. Only the height and shoe size may be relevantly equal to 0.5. Any question?
No.
Take a minute. You can just look at it, then we can move on to the next. Coming to question number 4, now take 1 minute to do it yourself. Tell me the correct answer, okay? Have you done it?
B.
B. So your answer is B. Let's check it. So we take a sample of cars driving down a highway. So a sample of cars are driving from a highway. Which of the following pairs of variables will likely to have a positive correlation? So we are going to search for the positive correlation. And what is the positive correlation? If one thing increases, one variable increases, the other also increases. The positive correlation is when both of the variable increases. So in the statement A, x is equal to age of the car, y is equal to value of the car. So as the age of the car increases, value of the car decreases, right? So this is a negative correlation. Amount of the gas in the car's tank goes to fill the gas with the goes to fill the tank with the gas. So amount of the gas in the tank is more, fuel required to fill the tank will be less, obviously. So it is again the negative correlation. Age of the driver, speed of the car. So as the age of the driver increases, speed of the car decreases because the young drivers can drive the car more speedily. So it is again the negative relationship. Year of the car was made, total distance car has been traveled. So as the year of the car increases, like if the car was made in 1900, this total distance driven by the car is more. So year of the car is less, total distance is more. So it is again the negative relationship. None of the above is the correct answer because we were searching about a positive correlation, but all of them are giving us a negative correlation. So we will mark E, none of them, that none of them is correct for the positive correlation. Give it a check and then look question number 5 too. First give it a check again so that you don't forget anything. If you're done with 4, now try question number 5. This is also similar as we have done before. Okay, so question number 5 is correlation. Okay, the clothing store is having a sale. There's a clothing store and we have a sale on the clothing store. All items are 30% off. The sale price of any item is only 70% of the retail price. What is the correlation between the retail price and the sale price of the items of the clothing store? So we have to find the correlation between the retail and the sale price of the clothing store. So what happens is we have learned 2 points in our notes. Correlation is a measure of the strength of the linear relationship between two continuous variables. So correlation, write down the points, okay? It's a measure of strength of the linear relationships. First of all, what is the range of correlation? The range of correlation is between -1 to 1. We learned this thing. Correlation is the range between -1 and 1. So if the variables are perfectly correlated, if the two variables, let's suppose the two variables are x and y, if they are perfectly correlated, that is, for every unit increase in one variable, the other variable increases by a constant rate, then the correlation will be 1. So if every unit increase, if every unit, I'm writing this down, every unit, write down 2, okay? Every unit increase in one variable, the other variable decreases by a constant. So one increases, the other decreases, and the correlation will be -1, perfectly -1. So if they are perfectly correlated, then it is either +1 or -1 because the range of the correlation is between -1 and +1. If they are positive, then it's +1. That is, one increases, the other also increases, then it's +1. Otherwise, it's -1. So for the given example, the sale price is 70% of the retail price. The sale price is 70% of the retail price. Hence, the sale price is 0.7% of the retail price. So can we write it? Retail price can be written as X. Sale price can be written as Y. So we can write retail price, which is X, multiplied by sale price, which is Y. So now all items at 30% off for the retail on the retail price of 70%. So we have 70% off on the retail price. It means it's 100 into 0.7, which will be equal to 70. So it is when we have 100% off. So if we have 120% off, it would be equal to 100 into 0.120 into 0.7 will be equal to 84. If we have 150% off, it would be 0.7, it will be equal to 105. If we have 180% will be the retail price, it would be 0.7, 70% off, it would be 126. So what is a correlation? Correlation can be calculated with the formula of summation x minus x bar whole square. So correlation between the retail price and sale price items in the clothing store will be 1. How you will get the 1 over here? What is the formula to calculate the correlation?
I equals to
What equals to?
I equals to
R equals to yes.
summation xi x bar square
Summation xi
x bar square
minus x bar or simple x bar.
minus x bar.
So you should say minus yi minus y bar square, right?
Yeah, over n minus 1.
So you can just put everything in the formula and you will get the answer equal to 1. So therefore, we can say that the correlation is equal to 1 over here. The correlation between the retail and the sale price of the clothing store will be equal to 1. Should I clear the board?
Yeah.
Okay, so the next one is easy. You all again have 3 points and you have to see which one is true. So take 1 minute to do question number 6. Okay. So a national mag consumer magazine obtained data for several variables measured on a random sample of cars. The magazine reported the following correlations. The correlation between car weight and car reliability is minus 0.30. So they're giving us the correlation. So but first of all, just remember the correlation is between -1 and 1. I just told you in the last MCQs that correlation is always between -1 and 1. So what are the interpretations? If the correlation is between, just write it down, -1 to 0.7, minus 0.7. It means it's strong negative correlation. If it's minus 0.7 to minus 0.3, then it's weak negative. It's minus 0.3 to plus 0.3, it's little or no? No correlation. Must write down these points, these are important. If it's plus 0.3 to 0.7, then it's weak positive. If it's 0.7 to 1, then it's strong positive. So these points are very important. They will have to do a lot of questions. I'm giving you 1 second. Please write them down, okay?
Okay.
Okay. So correlation between car weight and car reliability is minus 0.30. Correlation between car weight and annual maintenance cost is 0.20. Which of the statements are true? Lightweight cars tend to be more reliable. So what about the lightweight cars?
Let's start.
They are talking about lighter weighted cars tends to be more reliable. So correlation between the car weight and car reliability is minus 0.30. So the correlation is negative and the magnitude is 0.30. It means weight of the car decreases as the reliability increases. So for this one, which of the following is true? Weight of the car decreases as the reliability increases. So lightweight cars tends to be more reliable. So it's true. Heavier cars tend to cost more to maintain. So correlation between the heavier weight of the cars and the annual maintenance is 0.20. So correlation between the weight and maintenance is 0.20, which indicates that there is a positive correlation. So as the weight of the car increases, maintenance cost also increases. So this is true. The last one is car weight is related more strongly to the maintenance cost than to the reliability. So obviously it is related to the maintenance cost more strongly. It is 0.20 than to the reliability, which is minus 0.30. So it means all of the three options are correct. So option E will be the correct answer. Okay. See, there are no workings, no calculation. This is just about thinking, but you should have a very strong understanding of correlation. I'm coming to MCQs number 7. Should I move on? Everything okay up till now? Okay. So question number 7. I'm giving you 2 minutes. Please read it out and try to solve it. Okay. It's not that difficult. Hello, Abdullah.
Bien.